Section 10.4 is the last section of conic sections. We're going to be talking about the hyperbola. You should notice a lot of similarities between the ellipse and the hyperbola. For the definition, the one thing you'll notice will change is instead of the sum of the distances between two fixed points being constant, it's the difference of the distances. There's still two foci. There's still a center. Instead of a major axis, we call it a transverse axis, and then there's still two focal radii. The equations of a hyperbola and an ellipse are also very similar. The difference is that, again, it's a difference instead of a sum. So there's a minus in the middle instead of a plus. It still has to equal 1. HK is still your center. Another difference is we call a squared always the first denominator. So unlike an ellipse where a squared and b squared can switch, on a hyperbola, y and x can switch. So if x comes first, then it opens a left and right. If y comes first, then it opens up and down. We still call the distance from the center to the foci c, but because of the differences between an ellipse and a hyperbola, the relationship between c squared, a squared, and b squared is a plus instead of a minus. C squared equals a squared plus b squared. So if there is a minus in the graph equation, there's a plus in the c equation. Versus an ellipse, there's a plus in the graph equation and a minus in the c equation. So these are always opposites of each other. So here's a hyperbola. A hyperbola is basically an ellipse that's been cut in half and then split open, split in the opposite direction. Your foci, just like a parabola and ellipse, are still inside the hyperbola, but unlike an ellipse, it's on the opposite side. An ellipse goes center, focus, vertex. A hyperbola goes center, vertex, focus. But always the focus is inside the shape. Another difference is that the hyperbola has two asymptotes that the end behaviors follow. Instead of having a major axis, the line that contains the foci, the vertices, and the center we call a transverse axis in the hyperbola. But we still call the distance from the center to a vertex a. From the equation, it's how far you go from the center to a vertex, that's your distance a. And how far you go from the center to a focus, that's our distance c. For b, we don't actually have a point on the hyperbola for the distance from the center to b, whatever that value is from the equation, but that number helps us to create our asymptote lines. So when we go to create our asymptote lines, we go out a in the transverse axis distance, whatever letter that's under in the equation, both ways, and those are your vertices of your hyperbola. And then in the opposite direction, for whichever letter b is under, you go that same distance there, and then you can create a rectangle where your asymptotes go through the corners of your rectangle. Again, the relationship between a, b, and c for hyperbola is just the Pythagorean theorem. C squared equals a squared plus b squared. Also, if you have a point somewhere on the hyperbola, you have, just like an ellipse, you have focal radii. So the distance from the point to either focus is called a focal radius. And unlike an ellipse, where it was the sum of these was a fixed number, on a hyperbola, the difference of these is a fixed number. So the absolute value of r2 minus r1, because you always want it to be positive if it's the distance, is equal to 2 times a, or the distance from one vertex to the other. And that's true for any point on the hyperbola. So here we have one. We want to find the center, transverse axis, vertices, foci, and asymptotes of the hyperbola. First thing we want to do is complete the square to put this into center form. So go ahead and pause the video and complete the square in two variables to get this in the center form of an equation of a hyperbola. So if you complete the square, I group my x's together, and you got x squared plus 8x, divide by 2 and square it, you're going to add 16. I factored out this negative 3, so you got y squared plus 2y, divide by 2 and square it, you got a 1, but it's really negative 3 times 1, so you're going to add a negative 3 to the other side. So you end up with x squared plus x plus 4 quantity squared minus 3 times y plus 1 quantity squared equals 9. Divide everything by 9 so that this side over here is equal to 1. So you get x plus 4 quantity squared over 9 minus y plus 1 quantity squared over 3 is equal to 1. So we can read the center right off of this, x minus h quantity squared and y minus k quantity squared. So our center is negative 4, negative 1. A squared is always the first denominator, so a squared is going to be 9, and b squared is going to be 3, which means a is 3 and b is root 3. So when we go to find our vertices, we want to go in the direction of x to find our vertices because that's the first one listed. So I'm going to go 3 in the x direction to find my vertices. So I went 3 to the right and got negative 1, 1, and I went 3 to the left and got negative 7, 1. So now you can read the transverse axis right off of this. The transverse axis is the line that contains the vertices and the center. So in this case, it's just the horizontal line y equals negative 1. To find our asymptotes, we need to kind of find what I call still the kind of minor vertices. So I'm going to go root 3 in the y direction. So I went up root 3 and I went down root 3, and now we can create our box from this. So you're just going to create a rectangle that has this distance for its width and this distance for the height. And your asymptotes just go straight through the corners of that box. So you have one asymptote here, and then you have the other asymptote right here. So they go through the center of the box and then the two corners on a diagonal. So if you want to find the equations of your asymptote, you'll notice that for this first asymptote that has a positive slope, we went up a distance of b, or up a distance of root 3, and right a distance of a, or right a distance of 3. It also goes through the center. Both points go through the center. The second asymptote goes down from the center root 3, and then to the right 3. So using point slope form, they both go through the center, so I use my center as my point, y plus 1 and x plus 4, and then one of them goes plus root 3 over 3, and the other one goes negative root 3 over 3, so I just said plus or minus root 3 over 3 for my slope. If you notice, if I have a left and right facing hyperbola, then your equations of your asymptotes are just going to be y minus k is equal to plus or minus b over a, x minus h, where hk is the center and b over a is the b over a that you just read out of your equation. So the last thing is finding our foci. So again, we have a relationship that c squared is equal to a squared plus b squared, Pythagorean theorem, but it works for the hyperbola. So go ahead and solve this out and find your foci. So c squared equals a squared plus b squared, which is 9 plus 3, which is 12. So c is equal to the square root of 12. So your foci, you're just going left and right from negative 4. So negative 4 plus root 12 would be over here. Root 12 is about 3.5. And then negative 4 minus root 12, which would be about here. So about negative 7.5. And then for your graphing your hyperbola, you start at your vertex and then just follow your asymptotes out, almost like two little parabolas following asymptotes. So make sure you complete the square. We know it's a hyperbola because there's a minus in the middle. This side needs to equal 1. A is always your first denominator, and you go that direction in whatever variable this is. So we went 3 in the x direction, and we went root 3 in the y direction to help us create our two vertices, and then our rectangle to create our asymptote lines. And then our hyperbola, for our hyperbola, c squared equals a squared plus b squared. So here you have the same type of problem. So go ahead and pause the video and try to find the works for this hyperbola. So completing the square, I have y squared minus 2y plus, leave a space, you're going to divide by 2 and square it is 1. I factored out the leading coefficient of x, so negative 4. So then I have x squared plus 4x plus divide by 2 and square it is 4. But we really added a negative 16, so I added negative 16 to the other side. So you end up, once you divide by this 4, because you need a coefficient of 1 on this side, or a constant of 1. So you end up with y minus 1 quantity squared over 4 minus x plus 2 quantity squared over 1 is equal to 1. So you can read the center, negative 2, 1, straight out of that. A is always the first denominator, a squared, so you know a is 2 and b is equal to 1. We want to go 2 in the y direction because it's underneath y. We want to go 1 in the b direction. So go ahead, if you haven't already finished doing this one, go ahead and pause the video and continue working. So I'm going to go 2 in the y direction to find my vertices. So I went up 2 and down 2, got negative 2, 3 and negative 2, 1. So I noticed that my transverse axis is going to be the line that holds my vertices and my center. So in this case, it's the line x equals negative 2. Notice my x-coordinate of my center, my vertices, and my foci never change. And that's the exact same thing as my transverse axis. My foci, I found c squared equals a squared plus b squared, so 4 plus 1, which is 5, which means c is root 5. So I'm going to go up and down root 5, so 1 plus root 5 and 1 minus root 5, which is a little bit over 2. So there are my two foci. Again, your foci always need to be inside your hyperbolas. For asymptotes, I went up a distance of 2 to get this vertex, that's distance A, and then to go to the sides of my boxes, that's a distance of B, which is 1. So then out of that, I created my little box and then made my asymptote lines through the corners of the box in the center. So on this case, it goes through the center, so I have a y-coordinate of 1 and an x-coordinate of negative 2. And for this one, since it's an up and down facing parabola, I went up A and over B, so I got plus or minus 2 over 1. So y minus 1 equals plus or minus 2 times x plus 2. So for an up and down facing hyperbola, your asymptotes, instead of having a slope of b over a like the previous example, they have a slope of a over b, but everything else kind of stays the same. So here we have a hyperbola that has a center at the origin, a focus at 0, 5, and a vertex at 0, 3. So I know this is going to open up and down, so I know y minus k quantity squared is going to come first. So I put the general equation over here for our hyperbola. So given this information, we want to find the equation of the hyperbola and then finish graphing it. So go ahead and pause the video and find a and b in order to write the equation. So your A value is the distance from the center to one of the main vertices. So that distance is 3, so A is 3. And then the focus, the distance from the center to the focus is C, so that distance is 5. And then C squared equals A squared plus B squared, so you can plug in 5 and 3 to find B squared, and you end up with B to be 4. So then you end up with, you went 3 in the y direction, so y squared over 9, minus you go 4 in the x direction, so x squared over 16 is equal to 1. If you haven't already done so, go ahead and pause the video and finish graphing this. So then to draw your box, you go 5 in the other direction to find your focus, 3 in the negative y direction to find your other main vertex, and then 4 in either x direction from your center in order to find the width in the horizontal direction. So then connect that with your rectangle, draw your asymptote lines, and then your hyperbola goes through the vertices and then follows those asymptote lines. So this has been the last conic section, hyperbolas.